In this video, we're going to have a look at using the Suvat equations as well as finding the overall velocity, which is a little bit different to finding the horizontal and vertical velocity alone. So it's told you that a ball is served horizontally, and it's asking you to show that the time taken for the ball to travel to reach from where it starts to the net itself is 0.6 seconds. So let's split this up, into vertical and horizontal parts, starting with the vertical part of the motion. So when you're using the Suvat equations, one tip I'd give is you'd always need 3 known variables and 1 unknown variable in order to use one of the 5 equations. It would be useful if you have equations open on another tab. So we're trying to find the time in this case. Now the displacement is the distance moved from the starting position up to where you're measuring up until. So if we look here, we're starting here and we're measuring up to the point where it reaches this net. Because we're only considering the vertical part of the motion, what is that displacement, that distance moved from the start to end? Well, it starts off 2.51 meters above the ground and it ends up 1 meter above the ground when it reaches the net, meaning the distance between them is 1.51 meters. Now the initial velocity in the vertical direction is actually 0. The reason for that is because the ball is served horizontally, meaning it only has a horizontal velocity when it's moving to the right. It has no vertical velocity initially. We don't know the velocity of the ball as it reaches the net, so we leave that empty. Now in the vertical direction, it's moving downwards. Of course, if we look at it, it's moving in this direction and then in this direction, but in vertically only, it's only moving downwards. So we say acceleration is positive 9.81 because it's moving in the direction of gravity. If it was moving upwards against gravity, then we'd use minus 9.81. Now that we've got 3 known variables and 1 unknown, we look at the equation which involves s, u, a, and t, which is s equals ut plus a half at squared. Substituting into that equation now, replace s with 1.51 is equal to u times t, so 0 times t is 0, plus a half of a, which is 9.81, multiplied by t squared. Now a half times 9.81 is 4.905, so I'm just going to simplify this into 4.905 t squared. From there, you divide both sides by 4.905 and then square root both sides. And you get that t equals the square root of 1.51 over 4.905. Now, normally I'd say take the positive and the negative root, but because we're dealing with time here, you can't have a negative time, so you only take the positive square root. And that'll get you 0.57 seconds, which essentially rounds to 0.6, so that's completely fine. Let's now move on to B part I, where it's asking for the vertical component of the velocity as it passes over the net. So when it passes over the net, the velocity is in this direction here, meaning it'll have a horizontal component and a vertical component, and it wants us to find that vertical component. Essentially what we want is the value of v in the Suvat that we've considered, because our Suvat considers it moving from here 1.51 meters downwards to here, so v would give the final velocity, which is the velocity as it reaches the net. So let's write some of this down again. So we want to find v, the vertical component of the velocity. We know u is 0, we know s is 1.51, and we know a, again, is 9.81. Now, which equation involves s, u, v, and a? Well, it's v squared equals u squared plus 2as. In this case, that's equal to 0 squared, which is 0, plus 2 multiplied by 9.81 multiplied by that displacement value of 1.51. Now, when you square root both sides, we get that v is just going to be equal to the square root of everything on this right hand side, which is just the square root of this term here, because we don't need to really take into account of the 0. So square root of 2 times 9.81 times 1.51, and that'll get you to a velocity of 4.8 meters per second. It will be something around that. I did do it beforehand and I can't quite remember the exact values. Actually, I'm just going to check and calculate. I don't know what I'm doing in my head. So square root of 2 times 9.81 times 1.51. Oh, it's actually 5.4, sorry. So let's put that here. 5.4 meters per second. Lastly, as for the overall velocity as it passes over the net. So what does that mean, overall velocity? Well, like I mentioned before, it has a horizontal component of the velocity and it has a vertical component of the velocity. That vertical component is what we just found, 5.4 meters per second. And, oh, I just realized there's a bit of information above that mentioned that the initial horizontal velocity that it was sprung with was 18 meters per second. So I'm just going to make a little note of that here. Initial horizontal velocity equals 18 meters per second. Now, why is that important? Well, what we can always assume is that in air, horizontally, the horizontal acceleration is actually always equal to 0. HAR just stands for horizontal acceleration. That means that the initial speed horizontally, it stays constant throughout the whole journey. So even at this point where it reaches the net, the initial horizontal velocity still remains as 18 meters per second. The overall velocity now, if you form your own right angle triangle and you find the magnitude of this sort of vector that we formed, which is like the hypotenuse of this right angle triangle, you can do that by using Pythagoras because this is a right angle triangle. That will give you the overall velocity, taking into account the horizontal and vertical component. So you do the square root of 18 squared plus 5.4 squared. I'm just going to quickly do that on my calculator. I'd recommend you use that rounded value that you got rather than, the non-rounded value rather than 5.4. It'll lead to more accuracy. And that gives you 18.8 meters per second. That's everything for this question. But one thing I just wanted to add as a bonus, I'll do this in a different color. It might also ask you for the direction. I've noticed that it does that in, especially in AQA, A-level physics. The direction, how you find that is you find this angle using SOHCAHTOA, using the fact that this is the opposite and this is the adjacent. So you do tan of the angle is equal to the opposite of 5.8 divided by the adjacent of 18. You do the inverse tan of both sides and you get that theta is equal to 17 degrees. Once you get that angle, you then say it's 17 degrees below the horizontal because that's the direction that the velocity is actually moving in. The velocity again determines the direction. So we say 17 degrees below the horizontal would be the direction. Hopefully that all makes sense. If you have any questions with it, just let me know in the comments. Otherwise, be sure to like the video and subscribe. I'll post more content like this. I'll link a playlist underneath as well with more questions relating to mechanics.